Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Welcome to today's DevOps.com webinar, How to Orchestrate Data Pipelines with Automated Data Transfers Between Kubernetes on OpenShift and External Data Sources, brought to you today by Red Hat and Stonebranch. Before we get started, I need to go over a few housekeeping items with you. Just a reminder that this session is being recorded, so if you miss any or all of it, you'll be able to go back and watch it again. We'll be sending an email with instructions for how to access the webinar on demand, or you can visit us at devops.com/webinars, and it will be there for you. We are taking questions from the audience throughout. You can use the Q&A tab on your webinar console to submit questions to our panelists. We will get to as many as possible towards the end. And we are doing a drawing today for 4 $25 Amazon gift cards, so stick around to see if you are a winner. With that, I am pleased to introduce to you today Colin Coxage. He's the Director of Product Management at Stonebranch, and Niels Boer. He's the Director of Product Management at Stonebranch. Gentlemen, thank you so much for joining me today. I'm going to hand it off to you, Colin, and put myself on mute. Thanks so much.
Great, thank you. Well, hello, everyone. My name is Colin Coxage from Stonebranch, and I'm responsible for the Universal Controller component of our Universal Automation Center solution, which is effectively our automation engine. And my co-presenter today, Niels Boer, is responsible for our solutions delivery strategy. And today, we're going to be discussing and demonstrating how to automate file transfers to and from containerized environments, specifically OpenShift. I'm going to set the scene by discussing hybrid file transfer or hybrid IT world and the drivers for file transfers in this environment, and then share with you a real-world customer use case. And then Niels will dive more deeply into his demo with the architecture he's going to use for that, and kind of show you how to configure OpenShift for file transfers and then how to automate those file transfers. So for hybrid IT environments, the hybrid IT world presents really some new challenges for IT automation, and I'm going to take a few minutes to explore this new world. And we're going to kind of start with a bit of a poll question here. So, if you could answer what environments you currently use, whether it's, on-premises only, public cloud only, a mixture of public cloud, private cloud, or a mix of everything, just to give us a feel for the audience that we have here today.
Yep, you should see that poll coming up on your screen. We'd really appreciate it if you could take a few seconds. We'll leave this open for about 30 seconds and give folks a chance here to respond. All right. All right, well, that seems like a pretty good sampling. What do you think, Colin? I think I'm going to go ahead and close this out for us.
Sounds good.
And then we can go right over to closed here and check out these results. It looks like on-premises only got 15% of the responses, public cloud only 10%, public and private cloud another 10%, and a mix of on-premises and cloud was by far the majority with 65%.
Great, thank you. So, for many of you, hybrid IT is already here, obviously, and this is presenting plenty of new challenges for automation. So your applications, are no longer pinned to your on-premises infrastructure. Many are now deployed in the cloud, and more of your business is consuming applications as a service. And consequently, much of our infrastructure has become an on-demand resource, encapsulating as code and transient in nature. Many of you are also managing multiple cloud vendors, and we are seeing a growth in tools like BI, business intelligence, big data, analytics process, which are now very key IT services, which are driving innovation and competitive advantages for the business. Which means for automation that a new approach is needed, an approach that takes into account things like the fact that dynamic real-time automation is needed to automate new and evolving IT landscapes, that the infrastructure needs to be automated alongside the applications and processes, which is how we've traditionally done things. And new technologies means that new management and point automation tools are also being deployed. As we see new technologies come in, we're seeing tools grow up alongside those that deal with those environments, that these need to be orchestrated to ensure that you can get end-to-end automation, which in turn will enable visibility and analytics for all of your processes and workflows across all of the different environments. And particularly from the survey results, the majority of people are using a mixture of on-premise and cloud-based resources. So that also is a big challenge. Marrying those two environments together is a key requirement. And the shift is also, we're seeing, towards decentralized access to automation capabilities. If you like, it's a consequence of that movement of democratization of IT resources. And democratization has created a new breed of citizen automators who are potentially developers, data analysts, business users, and the like, whose productivity is increased with direct access to automation capabilities. But at the end of the day, automation and orchestration of services is all about the data. What we're doing in terms of the automation is we're making sure the data gets moved and processed across all the different hybrid environments, by all the different applications that need to see it, by all the data pipelines that you may have, whether that's feeding big data, feeding your analytics and various other things there, or even just purely exchanging data and information with your business partners, with your service providers, with your customers, etc. So basically, making sure that you can securely and reliably move that and track it from the different environments you have, whether it be on-premises or cloud infrastructures. So to that end, we're going to take a moment to view a quick video to kind of explain the approach to these challenges. Just a very short video, take I think a minute and a half to view that. So we're going to look at that now.
For organizations today, change comes fast, and you need to move at the same speed. That's why leading enterprises are accelerating their digital transformation by shifting to the cloud, connecting siloed data pipelines, and dramatically speeding up the secure delivery of new code. And they're doing it with automation. But there's a big hurdle. Effective automation hinges on comprehensive orchestration of complex workflows across a hybrid IT environment. Enter Stonebranch's Universal Automation Center, a modern real-time service orchestration and automation platform. UAC puts you in control. It centralizes all automated processes across your entire business, from on-premises to cloud to containerized microservices. Awesome, right? The UAC platform enables you to automate IT processes in real time with event-driven triggers. Design powerful visual workflows that span your hybrid IT environment. Empower citizen automators from any business group with self-service automation. Create, start, stop, decommission, monitor, and alter on-prem and cloud infrastructures. Orchestrate data pipelines between disparate applications and platforms. And visually control your entire program with a centralized command center style view. All this to help organizations control emerging technologies like cloud, big data, and artificial intelligence, and new methodologies like DevOps and Data Ops. Plus, UAC integrates with just about any application or platform, empowering you to break down automation silos and achieve true orchestration across your business. If you want to know more, don't hesitate to contact us. Stonebranch, real-time hybrid IT automation for whatever comes next.
So, managing and automating and orchestrating your jobs, workloads, cloud environments, big data pipelines, and file transfers is effectively what we do at Stonebranch, along with making sure that we can integrate into your DevOps methodology. But specifically for today's discussion, we're focusing on transferring files to and from your on-premises and cloud infrastructures. And this is what we mean by hybrid file transfer. So as we've seen, many of you have moved or are moving to a hybrid IT environment, and we're seeing this trend across all industries. But within hybrid IT, and specifically when talking about the cloud, there are a lot of subtly different use cases. So kind of for clarity, we'll go through a little bit of terminology. Hybrid cloud uses a mixture of public and private cloud. Multi-cloud, which is environments that people have, is where you hedge your bets between more than one cloud provider. Distributed cloud is another term that we hear, which basically means that your cloud is taking advantage of the different geographical locations that the cloud providers provide. Cloud native refers to applications that were specifically created to leverage cloud capabilities, microservices, and that kind of application architecture. And the overall umbrella, I guess, is hybrid IT, which basically means you're running a mix of these different infrastructures. Most commonly, this involves on-premise and cloud. And this is where we're seeing a lot of organizations are right now. There are, of course, exceptions. I'm aware of a few organizations that are 100% cloud, but for now, these seem to be the exception. Most people still have an on-premise infrastructure. It's going to remain for a while, but they're rolling out aggressively services in the cloud, or they're consuming services in the cloud. And this is kind of where the challenges come, is how do I marry the automation and orchestration of those different environments? So for today's discussion, talking about hybrid file transfer, when it comes to deploying applications in hybrid IT environments, the big challenges organizations are facing today is really in ensuring that they can connect and manage their on-premise and cloud environments seamlessly, that they can securely send data between on-premise and cloud environments and between different cloud providers, because a lot of companies are hedging their bets between the different multi-cloud kind of strategy. And basically, I'll do all this in real time while maintaining control, being able to visualize these activities from a single viewpoint. And all of this happens with an increasingly diverse mix of platforms and solutions that are being deployed. So let's kind of take a look at the approach that one company has taken in addressing some of these challenges. So as the second largest insurance company on the planet, AXA really needs no introduction from me. IT and automation are a very important part of what drives AXA's global business success. And they were very much one of the earlier adopters of a hybrid IT multi-cloud environment, which presented a whole bunch of new challenges which they had to, work out solutions for in terms of how they wanted to deploy their applications, how they wanted to manage things. Not least of which is the often overlooked requirement for integrating their legacy platforms with the cloud environment. This became quite a big challenge early on for them in terms of the discussions we had in helping them provide solutions to do that. Everyone gets excited about all the new environments, but the legacy environments often still remain at the core of IT services, and that's very much true with the environments at AXA. So AXA is a long-term Universal Automation Center customer across its multiple global entities. And for this use case, we're focusing on AXA Switzerland. AXA Switzerland uses our software as a service Universal Automation Center offering. And for the OpenShift file transfers, their use case involved secure transfer of data between on-premise IBM mainframes and servers hosted by 3 different cloud vendors for 2 different cloud applications, which they were deploying via the Red Hat OpenShift container platform. So the solution they implemented with the Automation Center was basically allowed AXA to leverage the infrastructure that they were already using to provide automation across their on-premise applications. So the universal controller component to define and monitor their automation, and the universal agents component to transfer files and execute workloads on the different platforms. The 2 OpenShift applications, was the MyAXA Business and the MyAXA Web, were deployed as OpenShift pods, with auto scaling and a whole bunch of other capabilities they were taking advantage of. And effectively, the solution they chose to implement was to implement a universal agent in a sidecar container to these pods, basically using the public Docker images that we also publish when we update our software. We maintain those and keep those out. And that sort of effectively And those environments or those images have also been certified in the Red Hat environment. So using the built-in data transfer components of the agents, they're able to handle the required file transfer securely without opening inbound ports, which was a big security concern they had when they were speccing out their containerized environments. Basically each time they scale up a pod or start a pod, the universal agent that is started with that in sidecar container dynamically registers with the automation application universal controller. And they effectively dynamically join or automatically join a specific, what we call an agent cluster, which is kind of a grouping definition. And when the pods are stopped, that's dynamically removed because these environments are not the traditional environments that you automate in terms that you have a fixed infrastructure. They're dynamic. They come up as they needed, they scale up and down as they're needed, and that needs to be taken care of in terms of how we manage the automation infrastructure as well. So this means that their definitions didn't need modification. Basically, they're able to dynamically recognize what agents are available for processing workload, and also which agents we have or which which pods we need to are there that we need to be able to look at from a point of view of managing. Oh, there's data that we need to move. There's data either created or we need to provision data on those pods, and that's all done dynamically and automatically as they're scaled up and down, which basically makes the automation very clean and simple. They don't have to worry about as the landscape changes, they don't have to worry about making changes to the definitions. We auto scale up with and scale down with the application as it does so. And with their usage of the SaaS automation center deployment, software as a service, AXA now, it gives them basically a central logging and security concept. It gives them a very highly available environment across 3 availability zones, so that in a disaster scenario, dynamically switches are made to another geographic region. All the communication is secured, and all of their users internally and all of their citizen automators are authenticated with their corporate single sign-on. So before I hand over to Niels to get into more detail in terms of the demo that we're going to do today, we kind of have one more poll question for you.
All right. Here is the second poll. Does your organization currently use containers? Yes, standard practice. Sometimes for some applications only. Not yet, but planning on it. Or no. So again, we'll give you all a few seconds to log your responses. See where we are at with containers. Right. Maybe just give it another few seconds. There we go. All right. Gonna go ahead and close out this poll. Thank you all so much. Let's see. Okay. So answers, yes. When asked if their organization currently uses containers, 35% said yes. 50% said sometimes for some applications only. 10% not yet, but planning on it. And only 5% said no.
Okay, and that really, I think, sounds, very sort of much expected from the point of view of the audience we expect for a webinar with this title. Yes, I mean that, we have a few that are into it, pretty much everything as much as possible. A lot of people that are using it, but, just for certain applications, and pretty much everyone else is, yeah, it's coming. We need to be aware of what's going on. So, at this point, I think it's, I'm going to hand over to Niels so that he can show you how to automate your OpenShift file transfers. So Niels, time for you to step on stage.
Very good. Okay, I hope you can all see my screen. Okay, so basically I'm going to show you now a demo, And before I do this, just to give a quick overview what I'm going to talk about it. So in this use case, I will be solving a challenge that a mass media company that receives real-time breaking news data all the time might have. So as a news feed comes in, it needs to be fed to the web servers hosting the web page. To provide a scalable solution, the web page is hosted on multiple web servers deployed in a Kubernetes cluster maintained by OpenShift. More servers you can deploy to the cluster if the load increases, for example. Or you can also remove remove clusters or remove servers from the cluster if the load decreases. What I will show in the demo is now how to update all web servers in the cluster, either from web page data from a Linux server or from an Azure container. So basically, if a web designer, for example, has created a new newsfeed, which he wants to deploy on the web server cluster, he can upload his web page data to an Azure container, and then automatically it's fed to the web servers running in the OpenShift cluster. And the same I would also show from Linux. So you can upload your web page data on a Linux server, and then from the Linux servers automatically transferred into all started web servers in the cluster. So this is the demo that I'm going to show you. We are not limited to Azure or to Google Cloud or to S3. Basically, we provide support for all the different private or public cloud providers. Also, IBM Cloud would be supported. So it doesn't matter where your data lies. We can transfer it from anywhere into the Kubernetes cluster. Before I start showing the demo, I have a very short overview on what OpenShift is, because maybe not everybody is really an expert in this OpenShift stuff. So I have just one slide explaining what OpenShift is. So basically, OpenShift is a platform that allows you to run containerized application, and it's powered by Kubernetes under the cover. One of the big advantages is that you can run OpenShift on public and private resources. And we also saw this in the poll, that you're using both also. Public can be, for example, Azure, an Azure platform, or private can be just your Linux server. On top of that, we have the operating system, which is in my case, that runs basically the Docker container. In my demo, I'm using CentOS as operating system, but it would also work on Windows. So also Windows would be supported to run the Docker environment. And on top of that, we have Kubernetes. Kubernetes uses basically the concept of pods. A pod can run one or multiple containers. And the nice thing is that this allows you to package a complete application containing of multiple containers in one pod. So in my demo, I will show you that I have this web server packaged in a pod. And you will also see that our universal agent also runs in the same pod, because it's just another container. Then Kubernetes is also used to scale up and down the applications and distribute the load over the different nodes. So, for example, if I want to now scale up the number of, let's say, web servers I have, I just tell in OpenShift, please start another pod in a Kubernetes cluster. So it's very simple. Or I can also scale down if the load decreases. Yeah, on top of that, we have now OpenShift. So OpenShift is basically a layer on top of Kubernetes, which builds a facade around Kubernetes. And it takes care about all these day-to-day jobs, like deploying applications and so on. Also, OpenShift has this nice concept of projects, teams, and users, which you will also see, which allows multi-tenant use of OpenShift clusters and to manage also the access privileges, I think, which is a big advantage. Also, OpenShift is used in many cases really as a platform as a service. And it's, for example, integrated with source code management systems like GitHub. It provides pipeline support to develop, build, and test. It's connected to Docker registry, and so on. So this was just a very short overview. Now let's have a look a bit more about our architecture. So basically, the first thing that you have your, let's say, Docker container, which are similar like a virtual machine. So these Docker container contain your different codes. Then you can bundle these Docker containers into a pod, and one pod might be one application. So, and you can have as many containers in a pod as you want. In this case, in the example, I have 2 containers in one pod, and one pod would represent, in this case, one application. Then actually you can distribute your pods onto a cluster, which consists of multiple nodes. These nodes are then maintained by the master, who takes care about the orchestration of the different pods. Now with OpenShift, you can, let's say, add more pods, start more pods, or remove pods from a cluster. Now comes our universal agent. So our universal agent is also deployed as a container. It's called a sidecar container, but a sidecar container is nothing more than just an additional container inside a pod. And this pod, this container, the sidecar container, we add to any pod in your that you want to that should receive data from somewhere, or that you want to use for scheduling. So in our case, when the agent is deployed a sidecar container to the pod, it can receive data from anywhere. So because we have this agent-to-agent file transfer. So for example, you can send now from a Linux server data to a pod, from a mainframe directly you can send data to a pod, from any cloud storage, so basically from anywhere. In addition, when you have this universal agent in a pod, you can also use it to schedule your application. So if your application has an API, for example, you can start a REST web service from our universal agent to schedule your application. This all works because in a pod, you can share the file system. So basically, this agent has to say can mount the file system directory, which can be accessed also by the other containers in the pod. Yeah, before we start with the demo, this is the, let's say, setup of the demo. So first of all, we have on the right side, I start here with the right, we have our application, which is basically a web server, and it's called /this application. So this is the container /image. This contains the web server. It's an Nginx web server. And aside with this web server, we always install the universal agent or deploy the universal agent as sidecar container to this /this application. Then we can start as many pods as we want. Let's say if the load increases, we would start more of this // container. In this case, I've started 2, but I could also start, for example, a third one if the load increases. All of these pods contain the // application and the sidecar container with the agent. Then here on the left side, I have my Azure container. So the website developer can upload his stuff to his index page and pictures, everything you need for a web page, he can upload to the Azure container via his client. As soon as it's there, then basically we send this data from Azure directly to the pod cluster. How we are going to do this? Because each pod cluster, as that you see here, is in our universal controller, which is here on top. This is our universal controller. It's a web application running in the Tomcat server. Is one, let's say, so-called agent cluster. So for each pod or for each application, we build one agent cluster, and this agent cluster contains all active universal agents. So in this case, our agent cluster would contain 2 universal agents because 2 of these agents or pods are started at the moment. If I would start this one, this agent cluster would dynamically get another agent. You will see it in the demo, then I think it gets more clear. Yeah, so of course, this stuff works also the other way around. No? So it's not only that you can send data from Azure to the pods, you can also send directly data from the pods to anywhere else, no? To any cloud storage or server and so on. Yeah, so now let me go to the demo, and I think then it gets clear how it all works. Just close this one. Okay, I will log into the Universal Automation Center. So this is our controller, which controls our the workflow. So as I said, it's a web application. It's also available as software as a service. So it runs, it's very simple to install. It just runs in a Tomcat. Of course, if you have it as a software as a service, you don't need to install anything. So you just start it via putting your IP address here. You can connect via SAML, or as you can see, I just use the local user. But you can also use an identity provider like Okta, for example, to connect. Yeah, then actually, before I start the demo, our controller or our solution is very simple. So basically, it consists of so-called tasks. This is what you want to start. A task can be running a Linux script, running a Windows PowerShell script, or maybe you want to start an Informatica job, or you want to do some big data scenarios like an HDFS file monitor you want to start. One task which we are using now is a so-called file transfer task. So that's just also another task which allows you to transfer data from anywhere to anywhere. In this case, I'm transferring, for example, from a Linux server into a pod cluster. Then you have the triggers. So the triggers are the ones that start the tasks. And the tasks can be started event-based, for example, on a file arrival, a message arrival in a queue, and an event in SAP. So basically an email arrival. So any kind of event you can use to start a task. But of course, you have also standard time triggers. So for example, start every first business day of the month, the task. So this you can also do classical scheduling. So event-based and scheduling. Our scheduler has one big advantage compared to many others. It's really second-based precision. So we don't have these old school 1 minute or something. You can really use it as a real-time system. Okay, so then we have so-called here dashboards. So I created one dashboard for the Newsflash application, which I want to show you. And the first thing I want to do is, let's say, I want to do a file transfer from a Linux server into a pod cluster. But before I can do this, I first of all need my application started in OpenShift. So this is why I'm now switching to OpenShift. OpenShift also had a very nice user interface. So this is the latest version. I just installed it 1 day ago. So 4.7. And to, let's say, create a project in OpenShift, it's very simple. So so the only thing that you need a project. And I called this project Newsflash. I created this before, but it's very simple. You just need to go to Action, Add Project, give a name, and that's it. Then actually what I also did before, which I will not show you now, I created a so-called service, because let's say if I start 10 web servers, I only want to have one single address to reach these web servers. No? So it's like a load balancer on top of all my started pods. Okay, so the only thing what I need now to do is to start this application, I need first of all a so-called deployment config. So the deployment config, what I'm doing, just need to click. So with the deployment config, what I'm saying is start my application, which is a web server. So this is my normal container, an nginx web server in this case. And now the only thing I need to do to add our universal agent as sidecar container to this web application, to this web server, is this small part. So this part, what you see here, is always the same. And it's very simple to configure. So the only thing that you really need to configure is, first of all, the name of your application. It's called Agent Cluster App Newsflash. That's the name of the application, because that's also the name of the agent cluster in my universal controller. And you need to tell to which, let's say, controller it needs to connect. So in this case, this agent will connect to my universal controller. That's the one that you just saw on this IP address at this port. And it's always outbound, as Colin mentioned. So we never open any inbound port to your OpenShift cluster. So basically, you only need to configure the name of the application and the where this agent should connect to. And then you just add this part to your deployment config. That's it. Then automatically a universal agent will be deployed into your OpenShift pod. There's one other thing, is this mount point. So this is basically where we share the data. So when I send data for the web page, I send it to this share pod. I called it pod share. And this pod share is then available via all the containers that have this share name. Okay, so then I just say create. Actually, I'm starting 2 pods. This is the number of replicas. So, and as you can see, it will not, hopefully it will not take too long. So it's scaling up. First one is already there, and that's it. So what we have done now is we created this web server, this nginx web server, and we assigned our universal agent as sidecar container in the same pod. And we have now these 2 pods. Let's have a look at the pods. So we have these 2 pods running. And if I go into one of the pods, then actually I have a log file for the nginx container. That's the application, my web page application, and for the universal agent. And as you can see, our agent, which was deployed as sidecar container, I have the whole log file here. So the whole log file of our agent, of our application, basically is available directly in OpenShift for maintenance and to look up errors and those things. I can also go to the terminal. And if I do a print working directory, for example, on the terminal, you see there's nothing in the app directory. So basically, there's nothing yet in the Nginx web container. So nothing will be displayed. So if I go now to the web page and press it, you see Nginx forbidden, which means there's no index data, no pictures, nothing is there to show. So what I will now do is I will now transfer data to all started pods. So in this case, to these 2 pods which I started, I will transfer data, and then the web application or the web server should be automatically updated with these web page data. Okay, so let me switch back to my other application, to my controller. Yeah, if I go now to my controller, then first of all, I will have a look at the so-called agent of my agents. And you can see on this controller, 2 agents have automatically registered because these were the ones that I started when I started the pod. The sidecar container was one of the sidecar container was this agent, and this agent says, connect me to this server here, port 7878, and now you see they're up. If I could now scale up another pod, for example, then I would see here 3 agents. Or if I scale down, I would see 2 agents. Let me quickly show you this. So for example, if I now go to the deployment config, and I say now I want to scale up another pod. You see it's now scaling up. This will start the sidecar container. The sidecar container will then try to connect to our universal controller. So if I now go back to the controller, I should see now 3 agents. And you see another agent has been added. Now all these agents that you see here are automatically assigned to a so-called agent cluster. And the agent cluster, that's the name of the application. That's the second parameter we gave in the deployment file. And you can see in this agent cluster, we have these 3 agents active. So if I now send a file, I can say, send this file to all active agents. So then the file would be sent to all pods. Or I can say only send it to the pod with the least load, for example. So that I can decide. In my case, I want to send it to all active pods because I want to update all web servers at the same time. So to do this, I've created a small dashboard here. And in this dashboard, I have a workflow which is called monitor for news flash data. Let me just start this workflow. So what I'm doing here, I have a small workflow. It's very simple. So it monitors for new web page data on a Linux server. So it monitors on a Linux server, which is called, you don't see it here because I put it as a variable, but you will see it when I run it. It's called SuperSnake, and I'm looking in the directory demo for the file index.html. As soon as the file is uploaded on the Linux server, then I will start the file transfer, and this file transfer will send the data from the Linux server to the OpenShift pod, to all OpenShift pods active in the cluster. Okay, now let me start this workflow. See? And now you notice something strange because you just saw the workflow, and now the workflow has 3 bubbles here because the system noticed there are 3 active agents or 3 active pods with sidecar containers. So it automatically creates 3 file transfer tasks here. If I would start another one, we would see a 4th one. So now I will transfer data to the Linux server. As soon as it's there, it will be transferred from the Linux server to all active pods. So I just use my FileZilla to transfer the web page data to my Linux server in the home Niels demo. Now it's transferred there. So you see the file monitor identified that the files are there on the Linux server, and it's already updated. So if already updated on the OpenShift page. So if I now go back to my OpenShift system, first of all, let's have a look at the web page if the data is there. It worked perfect. So you can see the news flash update was done. So all the data has been transferred to the different web servers. And this is the main address of all my web servers, which is then distributed automatically to all pods. And here is the news. So basically what you can see is this is the news from 1st of May. So on 1st of May, we launched the new Universal Agent 7. That's the one that you're seeing in the Red Hat catalog. And this is a Red Hat catalog page. So you can directly deploy also the agent either from the Docker Hub, as Colin mentioned, or you can use it directly, deploy it within your OpenShift from the Red Hat catalog. Okay, now let's have a look. If I go to the pods, and maybe I just click any one of them, and now to the terminal, and if I now press the ls, you will see the data here. No? So now this is this index HTML file and the Red Hat PNG, which you just saw here in this web page. So the data has been transferred automatically to all started pods. Okay, now let me go back. What I will do now, just to one thing. So I will go now to the deployment config again. Now let's say the load has decreased. So less people are watching the web page because it's not so interested anymore. So I can decrease the load. Now it's going to 2. So if I go now back to my universal controller and go back to my thing. Now what you can see is there are only 2 agents left. So if I go to my agent cluster, you see in the agent cluster there are only 2 because I scaled down the number of pods. So automatically in my agent cluster, this pod has been removed. So that means we completely dynamically add agents to our cluster when you add another pod, or remove agent from the cluster if you scale down the cluster. So it works really dynamically. Okay, so this was one thing. Now I wanted to show you another thing, is that if you update your pods directly from Azure. So I've created another, let's say, workflow for this. So first of all, I'll show you this task. So this is a workflow. So basically what I have a monitor for Azure. So in this case, this Azure monitor checks in the container Stonebranch PM if the web page developer has uploaded an index HTML file to this container. If he has done this, then we automatically download the index file to the OpenShift cluster. We download the related pictures of the web page to the OpenShift cluster, and afterwards we delete the data from Azure so that it's not triggered again. So let me launch this workflow. Of course, each time you launch a workflow, you can view it in real time. If you see, it looks no more complicated because it automatically creates additional tasks. Maybe remember we had 2 agents started. So this is why you see everything twice. So now let me go to my Azure Explorer. Now let's assume I'm the web page developer. So I go to my Azure Explorer and I upload my new web page data. So I go to select the files. So now the web page data, and I say upload. Check. Yeah, it's uploaded. So now if I go back to my universal controller, you see it has already identified. Now it's running the upload to OpenShift and everything is done. So if I now go to my web page again, let me just check and press enter. So you've seen it has been automatically updated, all the pods all the 2 pods which started the web server. And this is now the latest news. So you see this is one from today. So we have edited basically support for, just a small note, to Power BI and Tableau in your data pipeline workflows. You can see them here at the end. So this is just an example flow of a data pipeline. And we have now Power BI and also Tableau for support. In addition, of course, to the OpenShift file transfer. Yeah, so what you have seen basically, maybe one last thing I want to show you. If I go now into the environment or into the pod, for example, to the terminal and to an ls, now you see there has been new data edited. No? So now there is the big data PNG and the new index file. And the Red Hat PNG is still there. I have not deleted, but it's not shown because it's not addressed by the index. So like this, basically, it's possible to add data to all your pods. What we have done here in this demo is that we always send the data to all active pods of an application. We can also, just as I said, we can also configure in the agent cluster. The last thing I wanted to show. if we go to our agent cluster, then basically what you can say here, you can say distribution, any round robin, low CPU or network alias. So basically you can also just send it to the one with the least load or in a round robin way. This might make sense. Let's say if you, for example, have a shared file system between all your pods, then you might not want to send the data to all the pods. This is also possible. Yeah, this is what I wanted to show you in the demo in regards to big data. So I think now I will hand over back to the Q&A session to Colin. Just
Cool. Well, thank you so much, Niels. All right, so we do have some questions that came in here. I will read them out, and then you guys can fight amongst yourselves for who gets to answer. How's that?
Okay.
All right. So first, I see Stonebranch running in OpenShift. Do you also support any other cloud environments, such as Azure's Kubernetes or Amazon EKS?
The short answer to that is yes. So pretty much any of the container management solutions, or should I say all of them, from that point of view, we're not specific. Our focus of the demo being on OpenShift is that one of the things that we do see that OpenShift seems to be one of the more popular container platforms. That not the only one, and it's not the only one people are using, but we certainly amongst our customer base have seen a big uptake on the Red Hat OpenShift. But we support all of them. Is the quick answer.
Okay. And could you offer more insights on whether or not your solution has the capability to dynamically start agent file monitors when the pods are spawned up and down?
And the answer to that again is yes. So from that point of view, if what you want to do in terms of within the pods themselves, the container environment is dynamically monitor for data, then we have a solution within the product that will do that. And basically it just tracks as the agents register with the application, with the Universal Automation Center application. It tracks and uses that as a trigger to say, oh, okay, we now have an additional environment that we need to be monitoring for based on whatever rules you've defined. So hopefully that gives enough detail to answer that question.
Okay. Here's one. Can we examine OpenShift pods as a multi-agent environment? Which AI parts are already done and what is left to complete? I'm not, I may have parsed that question incorrectly, but
Right.
maybe give it a shot.
Okay, so this one's a little more tricky, I think, but well, I guess the typical use case would be that within a pod, you would have a single agent, I think, for automation capabilities, because effectively the sidecar that we sit in on the pod has access to all of the pod's resources, right, in terms of file system and so on, and we can execute things for the other containers within that pod. So, but that said, as you scale up and down pods as part of an application, you really can decide how you want to do that, whether you want to have an agent, in each piece, or how much sort of collaboration you have between the pods. So the communication in terms of us sending instructions down or monitoring and getting data back from the pods is done network communication, obviously. We use TCP/IP, and that's secured with encryption, authentication, etc., and all those things. So.
Okay.
Yeah. So hopefully I kind of, I think the question was a little vague and the answer may have been a little vague, and I apologize if it was.
That is all right. All right, let's see. Can you show what the OpenShift web console displays in the storage section? For example, to see what appears in persistence volume and or persistence volume claims. That may be one that we need to send to you and have you follow up later, but figured I'd throw it out there anyway.
Well, that would definitely be one more in Niels's sphere of expertise than mine.
Okay.
More of an expert on the OpenShift. But Niels, do you follow the question? Feel comfortable at providing an answer? It's something you can show.
Yeah, that's fine. That's fine. I will write an answer. I'll send a screenshot.
Okay, great. So we will follow up with that one. Niels will send a screenshot of what we have there.
Fantastic. All right. Let's see. I think we've got time for one more here. Could you? Oh, no, I think we already got to that one. All right, folks. Sorry about that. Well, with that, then, I think that's about all we've got time for here. If we did not get to your question, please know that just like the previous question, we will send these along to Colin and Niels, and they will be able to follow up with you afterwards. Just a quick reminder that the session has been recorded, so if you missed any or all of it, or want to go back and watch it again for any reason, you'll be able to do so. We will send an email with instructions for how to access the webinar on demand. You can also visit us at devops.com/webinars, and it will be there for you. And so now I'm excited to draw our Amazon gift card winners. This is the moment we've all been waiting for. So let's see. Our first winner today is Lauren T. Congratulations, Lauren. And our next winner is Charles D. Congratulations, Charles. Our third winner is Jose C. Congratulations, Jose. And our last winner for today is Judy K. Congratulations to all our Amazon gift card winners. We'll be sending you an email with instructions for how to claim your gift card. If you don't see it in your inbox, go ahead and check your spam folders. It might be there. All right. Well, with that, thank you all so much for attending, for spending your hour here with us today. And thank you so much to Colin and Niels for your awesome presentations and demo. Audience members, if you wouldn't mind, we're going to be showing you a quick survey, if you wouldn't mind taking a few minutes and filling that out for us after this webinar. We would really appreciate that. Again, thank you all so much. Hope to see you again soon. I'm Sharon Florentine, signing off.